Hello students.
Hello sir.
So welcome to the lecture. So this is a continuation of the previous lecture of the axisymmetric element. So far we are seeing about the finding unknown values for the heat transfer problem. So in the first step we are asked to find the K matrix. K is the stiffness matrix, right? So in order to find the value of K, there is a formula. The formula is 2 pi R A B transpose BB, right? So here this values are known. R is known, A is known, B transpose is known, B is known through the previous steps. Today we are going to see the value of D matrix. D matrix is otherwise called as yes. Yes. Stress, strain, matrix. Relationship matrix. Shankar, yes, tell me the formula for D matrix.
Sorry, E divided by
Yes, E divided by
1 plus gamma 1 minus 2 gamma. It's
matrix of
1 minus gamma 0. Sorry, gamma 0. Gamma 1 minus 2 0 1 minus 2 gamma divided by 2.
yes, good. What your place? So this is the formula for the specific relationship matrix of the axisymmetric element. So if you see the axisymmetric element, the specific relationship matrix is called as D matrix. So D is equal to E is the Young's modulus and this is the Poisson's ratio. So 1 plus sigma 1 minus 2 sigma into matrix of 1 minus Poisson's ratio. So if you see here, the diagonal values will be 1 minus the Poisson's ratio. The last diagonal value is 1 minus 2 into Poisson ratio divided by 2. And if you see that last one, the last column, if you see the last row and the last column, except the diagonal element, the remaining element will be 0. The rest of the element will be just the Poisson's ratio. Right? So this is how you have to remember this formula. Right? So here the data are given in the question itself. Just you have to substitute the value so that you will find the D matrix.
Start.
So I have substituted the values of the stress-strain relationship matrix. So this Poisson's ratio value is given in the question itself. It is 0.25. So I have to substitute the values. I am arriving this matrix. So this is how you have to compute the D matrix. So in this step, we have computed the D matrix. So in D matrix, if you see here, the values are in the decimal, right? So if you write in the decimal value, what will happen is it is very difficult to compute. So in order to eliminate the decimal values, we can take the common value outside of this matrix. So what is the common value here? 0.25. So if you take 0.25 commonly outside, the decimal is eliminated and the whole number is replaced in this matrix. So that is what the main thing. Another most common thing here is what is the matrix size? This D matrix, if you see here, this D matrix, what is the number of rows? 1, 2, 3, 4. So you have to remember this. This is row 1, row 2, and row 3, and row 4. Similarly, this one is column 1, column 2, column 3 and column 4. So totally it is a 4 cross 4 matrix. It is a 4 cross 4 matrix. Why I am calculating the matrix size is because we have to use the matrix multiplication rule, right? Because in this formula we have to find the value of the stiffness matrix for the axisymmetric element. So we know the formula of the stiffness matrix, that is 2 pi RA into B transpose DB. That is known. Whereas matrix multiplication rule, if you apply, what matrix will be applied to what? what can be multiplied with what, that we have to know, because here there are three matrices. So what is the order of multiplication, that we have to know. Yes?
Sir.
Let us see the size of the matrix, right? So what is the size of the B transpose matrix? It is 6 cross 4 matrix. What is the D matrix? We computed earlier, it is 4 cross 4. That is the previous step.
Yes, sir.
If you see that internal value, it is same. So this matrix can be multiplied. So you can multiply with B transpose and D matrix. Or else you can multiply this D matrix and the B matrix. How? What is the size of D matrix? 4 cross 4. What is the size of B matrix? It is 4 cross 6. The internal values are same. So if the internal values are same, then the matrix can be multiplied. So what is the product of this matrix? 6 cross 4. So this will be the product of this matrix. Similarly, this one will be the product of this matrix. It is a 4 cross 6. Right? So in this order only we have to multiply the matrix. So if the internal numbers are not equal, then the particular matrix cannot be multiplied. That is the basic rule. So you have to check whether the matrix can be multiplied or not. So these two internal values should be equal. So in the upcoming lecture video, let us see how the matrix can be multiplied and how the K matrix can be computed. Thank you.